To take the Stokes mode technique into an application, here's a small section of a backlight in which we're modeling the recycling characteristics of a top polarizer. The top polarizer is a hybrid polarizer which reflects one polarization and transmits another. The backlight slab is indicated here in dark blue. It has scattering dots on the bottom which cause light to exit the backlight. It has a reflective diffuser on the bottom to avoid losing light that leaks out the bottom surface. And then it has a stack of layers that we'll talk about in turn. The polarization splitter is indicated in green. A detector picks up the light which goes through that splitter so that we can evaluate the irradiance. Above that is an analyzer which allows us to actually look at the transmitted polarization state in terms of the leakage through a complementary polarizer. And that last surface at the top is the detector to pick up that polarization information. In between the recycling polarizer and the top of the substrate is a dummy Mueller polarizer. That dummy Mueller polarizer actually allows us to depolarize all light that comes downward so that it can interact with the scattering properties of the system without having to worry about polarization variations and issues that come up in polarization scattering, which is not something that we want to examine. So let's take a look at the 3D model. The top is an irradiance surface. It simply shows the irradiance that made it out of the polarizer without respect to its polarization states. And beneath it, we have the top detector, which picks up polarization information, the analyzer, which is used to discriminate the polarization information coming out of the backlight. In other words, to see through leakage the degree of polarization or the quality of polarization coming through the polarization splitter. This is the irradiance detector, and the polarization splitter is here in green. The Mueller depolarizer, which is a downward-only depolarizer, it has no effect on light coming up, only down, gives us the ability to split the system into a polarized area and an unpolarized area. And finally, as we look at the extinction diagram coming through the whole system, including the analyzer, the dummy analyzer surface, is this extinction. Note that the extinction is about 5 orders of magnitude down from the peak value. So when this device is viewed straight ahead, its polarization is very high because its extinction through a complementary polarizer is very low. In the corners, we get the classic Maltese cross kind of pattern. The leakage occurs in the off-axis areas in the 4 quadrants. So this is a good way to study the recycling characteristics of a hybrid reflective transmissive polarizer that reflects one polarization and transmits the other.